Hey everyone, this video is here to talk about dilutions. And so with dilutions, we're going to use the general formula M1 V1 is equal to M2 V2. And so what we're calculating here, or what we're involving, is the initial molarity. So this is all of the initial side. And then this is the final side. And so what we're going to be comparing is the initial molarity multiplied by the initial volume of something that we have. And we're going to be converting that to a final molarity and a final volume. Now, generally, when you're doing an experiment in a lab, you'll have something called a stock solution. You'll probably have like a 10 molarity hydrochloric acid, for example. That's in my lab right here. And so what we'll want to do is, for an experiment, we'll probably not know, okay, what volume of that 10 molarity do I want to start with? But what we might know is saying, hey, I want to get a 1 molarity hydrochloric acid solution, since that's a lot safer to handle. And let's say that I want 100 milliliters of it. Well, we can actually solve for this V initial, and we can figure out, well, okay, how much of this do we need to make a 1 molarity hydrochloric acid solution? Or how much water do we need to add to get a 1 molarity hydrochloric acid at 100 ml solution? So we have a dummy question here. We have 53.4 milliliters of a 1.50 molarity solution of sodium chloride is on hand, but you need some 0.800 molarity solution. How many milliliters of a 0.800 molarity solution can you make? And so right away I can see that we're in milliliters here, and it's key to remember that molarity is moles per liter. And so we need to convert that 53.4 milliliters into liters. And if we do the time sign line, we can see that 1,000 milliliters is equal to 1 liter. So this is equal to 0.0534 liters in total. And so what we're starting with is this piece of information here. We have the 0.0534 liter solution, and we know that its concentration is 1.50 molarity. And so what we have now is we want to generate a 0.800 molarity solution. The question is, how much of this volume can we actually go about making? And so what we do here is we have 2 units on the left, we have molarity on the right. We want to divide by 0.800 molarity, and we do that from both sides. 0.800. And when we do, I'll throw up my calculator on the screen here, make this a bit smaller for you. What we're going to do is we're going to take 0.0534, we're going to multiply that by 1.5, and we're going to divide that by 0.8. When we do, we get 0.1001. We get 0.1001. And we assume, because we're solving for this volume here, we would assume that our units of that would be liters, and in fact they would. What we're doing with our units is we are taking molarity, which is moles per liter, and we are multiplying that by liters. Well, that liters is over the fraction of 1, and so we have a liter on the bottom and top of our fraction, and so those cancel out, and the only unit we're left with in that case would be moles. Alternatively, with what we're doing here, we are dividing by moles per liter, and so what we'll end up having is a scenario where we have liters times moles per liter, and we're going to divide that by moles per liter like this. And so you can see liter on top, liter on bottom, those two are going to cancel out. Moles on top, moles on the bottom. And what we're left with is this really janky fraction here where we have 1 over liters. And if you remember from back in your grade 6 or 7 class, whenever you have a fraction on a fraction, this thing ends up coming to the top, and we end up with liter as our final unit. And so whenever you do these calculations, M1, V1, M2, V2, your units will always end up working out. If you're solving for molarity, you'll end up with a molarity here. If you're solving for volume, you'll end up with a number of liters here. That is how to do dilution equations.